night, the same thing. I have no idea what's happening with the system. It's giving me trouble. And it shuts down by itself, and it's the school's computer. I brought it home when they kicked us out. I don't know what's happening with it. I did the same thing last night. Okay, so let's solve for x, the second equation. So I have negative 2y plus 12. In the first equation, I replace this x by this, because x is the same with negative 2y plus 12. So x in parentheses, this quantity, negative 2y plus 12, and minus y equals 1. I think it's recording now. Okay, we'll see. So I will distribute. I get negative 6y plus 36 minus y equals 1. Combine like terms, negative 7y. Bring this over, negative 35, so y is 5. I go back to the substitution, which is this right here, with 5. Negative 10 plus 12, x is 2. And we get the same solution. No matter which method you apply, as long as we perform the operations correctly, we should get the same answer, no matter what. Okay, so now I owe you examples of the other two that we have not seen yet. So here's an example. Let's say 2x minus 3y equals 10. And I'm going to make a little calculation on the side. And let's say, okay, so 4x minus 20 equals 6y. I just made it up and I had to make a little calculation so it works. Okay, so I see the system. First of all, it's not arranged in the correct order. This is okay. Term with x, term with y, and no variable. But this is twisted. So I will rearrange the second equation and write 4x minus 6y equals positive 20. And let's suppose this time I decide to eliminate, I shouldn't use substitution. I shouldn't even think of substitution. But let's say we want to eliminate, in this case, x. If I want to eliminate x, obviously I have to multiply the first equation by negative 2. When I multiply all terms by negative 2, I get negative 4x, I get positive 6y, and I get negative 20. I copy, especially here, but because I use substitution, I really don't need to copy both of them all the time, but here, when we use elimination, we have to. But here's what happens. So I'm telling you that 0 equals 0. So coming back, why do I put it in a recycle bin instead of waiting? I don't know. Coming back to our three situations, which case is it? Obviously, it's not this. We didn't find a solution.
It would be parallel?
It will not be parallel because parallel will not have solutions. We didn't get in a contradiction. If I tell you that 0 equals 0, what will you say? You'll say, yeah, that's true. 0 is 0. So it's this situation in which if you, that's how I created the system. Now I can tell you what I did. I multiplied this equation by 2. See? 2 times 2x is this. 2 times negative 3y is this. 2 times this is this. So it's basically the same line. No matter what you do, it's only one line. I fabricated another equation, but it's not a different equation. It's the same thing. So it's the situation in which it's the same line. So we will say infinitely many solutions. We didn't get a solution per se, but we didn't get a contradiction. Now I'm going to create another system. I'm going to work on the same one. 2x minus 3y equals 10. And 4x minus 6y equals 15. Yes, let's say we want to eliminate x. We multiply both sides by negative 2. We get negative 4x plus 6y equals negative 20. I have to keep together both equations so I can add. And look what happens. Totally different case than this one. This one was a true statement. If I say 0 equals 0, you're going to say, okay, yeah, I agree, so what? But if I tell you that 0 equals negative 5, you're going to say you lost your mind. So then what case is this?
Parallel?
Yes. No solutions. Inconsistent. Inconsistent system. Exactly. This is consistent. It has infinitely many solutions. The equations are dependent. Dependent equations. Here we don't have a name for the equations when they are parallel other than parallel lines. And no solutions, inconsistent system. So that's how we know that this has one solution. That's how we know that this system has infinitely many solutions, meaning the lines are the same. I just faked it. I made up another equation, but actually it's the same equation. And here, when we get something like this, which is a contradiction, we know that this system cannot have solutions. Lines are parallel. They will never meet because they are parallel. Very good question, Vinny. Thank you. Do we think we need more work? We've seen this before in other courses, but do you in intermediate algebra and others, do you think we need more examples with elimination and substitution? Let's look at another word problem though. On page 559, a hotel has, let's look at problem 79 on 559. A hotel has 200 rooms. I take notes when I read the problem. Those with kitchen facilities rent for $100 a night. So I'm going to call them type 1. $100 per night. And those without kitchen facilities rent for $80 a night. So this is type 2, $80 per night. On a night when the hotel was completely occupied, revenue was $17,000. How many of each type of rooms does the hotel have? So this is revenue when completely filled up, when no vacancy exists. Okay. How many variables we have in this problem? How many unknowns? We have two unknowns, right? The number of rooms that rent for $100 a night, and the number of rooms that rent for $80 a night. One with kitchen, the other one without. So we have two unknowns or two variables. How many equations we have to write if we have two unknowns?
2.
Excellent. So let's write two equations. Can anyone give us any of the two? Any of these two equations? Well, we do know that x plus y must equal,
200.
of course, there is nothing else, that's all they have. And now let's talk in money terms.
Would it be 100x
Excellent.
plus 80y?
Excellent, that's it. Now let's solve the system. You can use substitution or elimination, it doesn't matter. What I would like to do is definitely divide both sides by 10. And personally, I would multiply the first one by negative 10 to eliminate x. Negative 10x minus 10y equals negative 2,000. 10x plus 8y equals 1,700. Is this okay so far? Believe it or not, my camera is recording. Maybe I didn't click. Maybe I didn't click correctly this time. But yesterday it shut off by itself.
So to get the bottom, you did you multiply the bottom one by negative 10 as well?
There is no need. I will not do that. Because if I multiply this one by negative 10, I will not get negative 10 and 10. Since I have here 10, I want here a negative 10. Because only negative 10 plus 10 will be 0.
Okay.
So in order to eliminate this 10x, I have to have a negative 10x here. Is that better?
Yeah, I just didn't know. I didn't see what you did to cross off this.
Oh, I just to simplify by 10 to simplify the equation. You know, I'm in the business of simplifying and factoring. That's my
Okay.
that's my business.
Sorry.
No. Is it clear? I'm sure this is a question on other of your colleagues' mind too. So
Yeah.
I simply took away the 10 to make it easier. So what was left was a 10. That's why I multiplied the first equation, both sides, by negative 10. This goes away. I have here negative 2y, and here I have a negative 300.
Okay, so you divided, you took the negative 10 and put it under the 10, but that could be 0.
I looked at this 10 and I realized that I needed a negative 10 here, but I cannot just multiply one term. I have to multiply all terms, everything.
Right.
So I multiplied this by this and I got this, this by this and I got this, and this by this and I got this.
Okay.
Then I copy the second equation, 10x, 8y, 1,700. Now these two go away, negative 10y plus 8y. And when I calculate here, I get negative 300.
Okay.
And when I divide both sides by negative 2, I get 150.
I have a quick question.
Yes, please.
Will there ever be a situation where you would subtract there, like that, you know, right where it's a negative 10? No. So you know how you add those together?
Yes.
The negative 10 and the 8?
Yes.
So would there ever be a situation where you would subtract it, or is it just always adding?
I just have to perform what I see. They may be negative 10, negative 8, so I have negative 18. They may be positive 10 and positive 8, and I'll have positive 18. I have to perform the operation I see. So here I had 6x plus x. I just have to add. I have no choice.
Okay.
Then here I have to add whatever I see. Negative 4 with 4 is 0, negative 6 with 6 is 0, negative 20 with 20 is 0. So I perform the operation I see at every time. It could be adding, it could be subtracting, it could be anything. So on this one was adding. That's what it turned out, because we multiplied this by a positive number. So, and they were both positive. So when I multiply 3 by 2, I get 6, and 6 plus 1 is 7.
So if that was a -6, you would subtract that.
I would have to perform what I see. -6 plus 1 would be -5. Yes.
Okay, that,
I can change after I multiply both sides by a number, and then when I am down at this stage, I just have to perform what I see. It's 2 plus 12. It's not, it doesn't say 2 plus 12, but actually it means 2 minus 12.
Okay.
It's a very good question. So I have to perform what I see, because you're probably thinking of long division, and you're right. Right? We write or it says change the sign, blah, blah, blah. But in this case, we are just performing what I see, because the -2 plus 2 is 0, and the 6 plus 1 is 7, and the 2 plus 12 is 14. Here I have -10 plus 10 is 0, -10 plus 8, -2, and I have -300 here. Is that better?
That's good, thank you.
Perfect. So now I have to go back with y in here. And if this is 150, then this must be what? If this is 150, this is 200. Exactly. So we claim that there are 50 rooms with kitchen and 150 without, but you can say, who cares, show me. And then I'll show you by going back to the original system. And 50, 100, and 50, 50, 150, 50, 150. There is no reason for me to check the first one, it's obvious. But for the second one, if you'd like, 100 times 50 plus 80 times 150. If the answer is 17,000, then I'm in business. If the answer is not 17,000, I have to start from scratch. But it turns out that it's correct. Moving on, or we need another example.
In that, in the one you just did, you can use -8, right, instead of -10. It just makes it harder.
You mean in here?
Yes, right in there. Like you could have used -8.
Yes. You could have eliminated y, but it's always multiplication by 10 is always easier than multiplication by 8. This is how lazy
Right.
people think.
Right. Yeah. Okay. Thank you.
Sorry about that. You know, you can do whatever you want, but for me it's easier to multiply by 10 than by 8. It's the same thing, because this is 8 and 8 and this is 1600. It's not a big deal.
Okay. Thank you.
But yes.
It's like making things
Yeah,
harder
but
for myself.
yeah, multiplying by 10 is just add a 0, so you don't have to think. Okay, so let's look at another. Yes? We want to look at another word problem, or we move on? Okay, I hear moving on. Okay, so let's look now at 5.4. Systems. We will, when we review for the test, we're going to go over other problems. Systems of linear. Oh, I'm sorry. Systems of nonlinear. That's what I meant. Nonlinear equations. Everything is the same idea, but of course we're not talking about lines here. We're talking about more sophisticated situations. The same method, substitution and elimination, everything the same, but you will see what happens and why they are different in a minute. They're not lines. Okay, so let's start with number 6 on 587. And here it is. Y equals x squared plus 4x plus 5, and y equals x squared plus 2x minus 1. So obviously these are not lines. Let me start a second video.